FRQ number 2 on the AP Biology exam is not an art contest. It's a communication test. Hi, I'm Miss Parrott, and in today's video, we're going to be looking at how to make an FRQ number 2 graph by hand so that it's fast, neat, and scorable. But first, what earns you points? There are so many things that need to be included in a graph. And you're right. But what's actually going to earn you points are choosing the correct graph type, labeling the axes correctly and with the units, and then plotting the points or making the bars, scaling correctly, and including error bars if that's required. And that will earn you 3 points out of the 9 on FRQ number 2. What does not earn you any points is a amazing title or a terrible title. You don't need a title on an AP Bio exam FRQ. Now, you do need it on a lab report and you do need it in real science. But today we're focusing on what's required for the AP Bio exam. You don't need color. You also don't need perfection or extra zhuzh. But you do need neatness. All right. So the first step is to decide your graph type. Now, I did a whole video on this and I went through all 8 types of graphs that could appear on the AP Biology exam. So your first decision, the first thing you need to do is look at the data table and the text above the data table, because sometimes they don't cram everything in the data table. So your first question is, which of the variables is going to go on the x-axis? Again, I have a whole video for this. And then once you figure that out, then you determine, is that variable categorical, meaning it could be put in distinct groups, or is it continuous? Remember, continuous and numerical is not the same thing, because you could have group 1, group 2, group 3, group with 3 eyes, 2 eyes, 1 eye. That's not the same as continuous. So be sure that you determine that next. If it's categorical, so if you have 3 distinct groups or 2 distinct groups, however many, most likely on an AP Bio exam, that means you're going to make a bar graph. Now, while box and whisker plots and pie charts do show up on the AP exam, you're not going to be, it's very unlikely that you'll be asked to draw one by hand from scratch. Because it's not like you have a protractor to be sure you get all your pie pieces from it. Then if it's continuous, you're most likely going to be making a line graph. Now, you could also, there's option for a scatter plot, and then a histogram is another type of continuous graph, but when it comes to what you're going to have to make, it's going to be a bar or a line graph. Now, just because it's a bar or a line graph doesn't mean it's going to be simple, because you may need to plot 2 data sets. And if that's the case, you're going to have to put those together, but separate from the other groups, and you're still going to need a key. You're going to need to choose how you're going to differentiate, and you may need to add error bars as well, which is a whole other layer, and we're going to get into that in just a second. So once you've decided your graph type, then you're going to set up your usually 20 by 20 square box. That's usually what's given on an AP Bio exam. However, it's always good to check, just do a quick count and be sure it's 20 by 20. When making your graph, although you are allowed to use a pen on the FRQs, and I would actually encourage that for like their long written part so that the readers are easily able to see what you wrote, when you're making the graph, it's okay to use a pencil, but be sure your pencil has a good eraser. So here is a setup routine. The reason I'm giving you a routine is so that it can be something you practice all year long, and then when it comes time for the AP Bio exam, this program is already written in your mind, and you can go through it quickly and easily, because time management is a huge part of AP Bio fluency. So the first thing you're going to do is leave some space on your axes for your actual numerical values and group names and stuff that you're going to write. Then label, so just outside of that, you're going to label the X and the Y axes. Use whatever words they actually use on the data table, or in, like, don't try and like make it super short or come up with something creative. Just use the words that they use. And don't forget to include units. Put those in parentheses so they know. Even if the units are just amount or relative amount, or percent or frequency, put that in parentheses as well. Then you're going to use the 20 square interval method that I introduced in the video just before this one. Check out that up here, okay, to help you label your intervals. And again, we're going for clean intervals, easy math, something that's easy to both read and write and not accidentally skip numbers, and that will take up the majority of the space, between 50 to 100%. Again, our target range is like 70 to 90% of the space in the graph area. So once we've labeled our intervals, again, do that spacing check. Is it 50% of the space or more? If so, great. If not, don't start plotting yet. Redo your intervals. Then once your spacing check is good, and to do that, you really just need to see, like, where's my max? Where's my min? Like, where is this gonna ballpark, right? Then you're gonna plot your points and add your error bars. If that's required based on the data table. And a lot of times it is, so practice that. All right, so we are going to go through what I would consider a very AP style example. So let's imagine that this is an FRQ number 2, and it's looking at the effect of temperature on metabolic rates in toad liver cells. Now, usually they'll give you some big paragraph, but I didn't want to waste space on that. So it's going to give us, we got 3 groups of liver cells that were exposed to different temperatures. 3 groups. So that's going to tell us we've got groups, categorical. All right. And then we have our 3 different temperatures, right? Our 3 different groups. And then the ways they were measured, what was measured was oxygen consumption rate in nanomoles of oxygen per minute per milligram, plus or minus 2 standard error of the mean. Yes, that is very AP style. Now, to make this even more AP style, we wouldn't just say toad liver cells. We would say some species name for toad and hepatocytes or something like that instead of liver cells, because they'll do anything they can to make it more complicated than it needs to be. Why? I don't know. But they're going to give you some crazy unit that, but here's the beauty. You don't have to know what that even means. Just know that's the unit. And so don't forget to put it on the axis. All right. And then plus or minus 2 standard error of the mean. So when you see plus or minus this number to the right, that's your 2 standard errors of the mean. All right. So we got oxygen consumption rate and ATP synthesis rate. Now our units are the same. So that's good, because that means we don't need to make a dual y-axis. We can make a single y-axis with like 2 different, like with a key. So that's nice. So let's think. All right, what's going to go on the x-axis? Again, this is going to be our, how we organized our data, how we set up our experiment. And we set that up by these 3 different groups of temperatures. So temperature is going to go, and again, these are numerical, but they're not continuous, right? This is not a histogram. This was like, this group was exposed to 20 degrees. This separate group was exposed to 25, and this other group was exposed to 30. So you have to read to be sure you know which it is. So temperature is going to go on our x-axis. This is categorical because it said groups. Okay, now which type? Let's think back to our previous slides. So we've got our list of things. If it's categorical, we're most likely going to do a bar graph. But we have two sets of data here. So we're going to need to do what's called a grouped bar graph, where you're going to have 2 bars per group. So grouped bar graph, because we've got 2 sets of data. And just to get our start in thinking about our scale, what is our numerical minimum? So 12.6 minus, so the minimum is including, right? Because we got to think about our error bars. So 12.6 minus 1.6 is 11.0 is our minimum. Now that doesn't mean that's our scale minimum, that's our data minimum, okay? And then our max is going to be 22.1 plus 0.7 plus the error bar. So 22.8 is our actual data max. That doesn't mean that's our max in our range. We're going to have to go beyond that. But this is just going to help us ballpark what our scale needs to be. Okay, now with these things in mind, we've already made our first decision, what type of graph, right? We're going to make a grouped bar graph. Now, I've already made this, but I would love for you to walk through with me out. So on your paper, as you're taking notes on this, like do it step by step with me. Because again, like physically modeling, going through the steps is going to help you. Okay, so we decided what kind you want. Then step 2 is we're going to leave some space around our axis, and we're going to label the X and the Y. So we have our temperature with degrees C. So our units are in parentheses. And we did 3 groups, 20, 25, and 30. Since this is a bar graph, not a histogram, there needs to be space between the 3 groups. Don't squish it all together. That's a different type of graph with a different meaning. However, since we're looking at 2 different data sets in each group, you can put those next to each other. It needs to be clear that, you know, the oxygen consumption rate and the ATP synthesis rate is the same, or is in this same group 20, right? The 20 group. All right, so we've done our label. And yes, you need to write the whole long unit, nanomoles of oxygen and ATP production per minute per milligram of mitochondrial protein, because that's what the thing is actually saying. So yes, even if that's as long as the other part, you got to write it to get to point. But just that right there, just labeling correctly, that's a point. Hooray. So step 3, we're going to add our scale and intervals. So remember, scale is our, like, we're going to start at this number and we're going to end at this number. It's the range of numbers that we're going to use. And then our intervals are like what we're going to count by. Now, if we use the 4 interval method and we do 22.8 and we divide that by 20, right, because that's our max. 22.8 divided by 20, that gives us 1.14. And needless to say, that is not a clean interval. Also, we don't want to end at 22.8. We want it to be a little bit beyond. So remember, we divide by 20, we round up to a clean interval. Now, so there are plenty of different ways to do this correctly. So whatever makes sense to you, do that. So for me, I decided, okay, so yes, 1.25, also not a clean interval, right? But if you do 1.25 times 4, that equals 5. And 5 is a clean interval. Hooray. So I did that. And so every line is 1.25. I did not mark every one, okay? But then that means every 4 boxes is worth 5 nanomoles of oxygen, blah, 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 right? So I could go 1, 2, 3, and on the 4th one, that's 5. Go up 4 more, that's 10. Go up 4 more, that's 15. So that's what I chose to do. Again, you can choose to do the intervals any way you want, as long as it fills at least 50% of the space. So if you wanted to make them 1.5, I think 2 might overdo it, because then your max would be 40, and then your highest bar is 22.8, so that's just barely going to break that 50% barrier. So 2 might be too high. Think about it. Do what works for you. I did everything is 1.25, but again, I didn't label every single one. I labeled my 5, 10, 15, 20, and 25. Then I went in, and halfway between those, I put the halfway mark at every 2. Just to, because when I'm actually plotting my points, I need some more specifics. All right. So scale and intervals actually, I think, takes the longest amount of time. So that's why you have to practice doing weird intervals with weird numbers. You just got to practice, and then it will become quicker and easier in your mind. Moving on. Number 4, plot. In this case, we're making a bar graph. So we use our data table. Now, since we have 2 sets of data and we need error bars, we're going to need a key. Here's what I chose for so you got to make a key. So first, yeah, I guess you could plot them, but be sure you already know like which one is oxygen and which is ATP. Like, you need to make that clear to yourself. So I guess these kind of go together. So plot your means. Okay, plot those first. Then go in with your key. So I decided that oxygen consumption would be the shaded one. Okay. These are things you have to think about. Again, the goal is readability by the reader who wants to give you points, but you have to prove that you earn them. If they can't see the error bars, like the bottom part of the error bar, because you colored in the thing so thick that they can't see the bottom of the error bar, they can't give you the point for error bars. And you wasted a whole lot of time doing some like really serious coloring. You also don't want to just, that looks like garbage. So when shading, I prefer just a simple diagonal line that, is spaced out enough and stays within the lines of the bar, please. And then the other one to be open. So it's a very easy distinction. Like, please don't do half the bars this way and half the bars this way. That gets confusing, especially when you don't have any color. So one thing mildly shaded, one thing open. And be sure to add a key so it's clear which is which. All right, then it's time to add your error bars. Now, error bars are super important. Don't just slap them on. You need to plot those correctly too. So even though your data table had 6 boxes, those are just the means, and then you have plus and minus 2 standard error of the mean. So then you're actually plotting 18 points, like grand scheme. So that's why you also have to practice doing this to get your timing really good. So anyway, your plus and minus, they need to be like as close to accurate as possible without getting paranoid about it. You want to be sure that the story your data is telling is the story that's showing up on here. So, you know, maybe like in all of these, the values are actually pretty close to each other. But if one is higher, that bar needs to be higher. And if one has a greater standard error of the mean, then that I bar needs to go farther than the other one. So be sure that your picture visually matches what your words are saying. And if you plot it correctly, that would be fine. But I also know that like you can't get every single tiny decimal, you know, in there perfectly. Sidebar for fun. Like, you're not allowed to have a ruler in the AP Bio exam, but you can use the side of your calculator as a straight edge when you're drawing your bars and error bars and stuff. So that's fun. Okay, once your error bars are done, you do just, you go through your mental checklist and make sure everything is there, and then you get on to the writing part. Now your goal is to be able to do this under time pressure. And we're going to talk more about that in a second. I want to give you some warnings about error bars and when you're working with two data sets. So the goal of an error bar is to show the variation from the mean, the variation in the data from the mean. And it's really important because whether the differences in the data are significant or not depends on whether or not those error bars overlap. You want to use the exact plus and minus value provided. You don't need to do extra math. So on that data table, you know, it said the amount of oxygen consumption plus or minus 2 standard error of the mean. So if it gives you plus or minus 2.2, that is already, so 1 standard error of the mean is 1.1. 2 standard error of the mean already is 2.2. Like, they've put that in the data table. You don't have to double that. There's no extra math needed. Use the numbers in the data table. Again, your I bar must be visible. So be sure that you make those nice and dark and that you don't color in or shade in your bars completely so that the bottom part of your I bar is invisible. When you have two data sets, you've got to have a key. If you were using a line graph instead of a bar graph, like one line being solid and one line being dashed is good. Don't try and make it like with different shapes and stuff like that. Keep it simple, but include a key. Remember, if your error bars overlap, you want to be careful about the way you word your conclusions, because the last 6 points of the FRQ number 2 is like, so what does this mean, right? And if your error bars overlap, even if your means are different, you want to be careful. And you know, you could say there may be no significant difference because the error bars are overlapping. Now, once you've done it, give yourself it says 60 seconds, but it could be even less. A 60-second graph check. Okay. Did I pick the right type? Yes, 1 point. Did I label the axes and units correctly? Yes. All right. Did I put parentheses around the units so they know it's the units? Yes. Okay. Whew, good. That's 1 point. Okay. Are my intervals uniform and not cocoa bananas? Yay. Are my data plotted accurately? Are my error bars there and visible and accurate? Do I have a key? Most important, like all that is like 1 point. And you can't just like leave part of that out. Like, you gotta have it all to get the point. Most importantly, is this readable by another person enough to where they could draw the same conclusions as you're about to draw in the explanation afterwards? Because if your graph is telling a different story than you're writing, you need to revisit your graph. Remember, the best way to get good at graphing quickly and accurately with weird data is repeated AP style practice. You gotta practice, and it needs to be timed, because time pressure, I mean, maybe not initially, but like after you get pretty good at the steps, then you want to add time pressure to it. And you want to be able to graph a graph like that in 10 to 15 minutes. Like 12 and a half would be great, because even though it's 3 points, it's going to take over half the time probably to graph a graph like that. Because again, it's like actually you're plotting 18 points and you're having to make all of these mini decisions. And yeah, you got to write out nanomoles of oxygen per minute per milligram of mitochondrial protein. So it's a lot going on. The more you practice, the better you'll be. So I hope that helped you with graph number 2. Please check out the playlist for this to get the detailed breakdown of how to do the 20 by 20 setup and your interval, like how to do your intervals and all the other, how to decide what type of graph you want and all of that. So check out the playlist. Please, if you found this video helpful, give it a like, subscribe to my channel for more videos on all the AP Bio, like skills, exam skills, quantitative skills, all the stuff that's kind of beyond what your book tells you. Please do leave a comment, a question, or an emoji down below. And if you'd like some practice graphing, some resources, check out my Teachers Pay Teachers store, Know and Grow with Gnomes. Keep learning, keep growing, and we'll see you next time.